Hi, everyone. Hope you guys are having an awesome Wednesday so far. So, what I did for today was I went over how to do the test, okay, or the answers to the test, okay. So, what I'm going to do here, real quick, is I'm actually going to present my screen so you guys can see what I did and how I did it. Now, the question arose, what am I going to do about sig figs, okay? And to be honest, I'm going to be very lenient when it comes to sig figs, mainly because uh, I didn't have you guys show your work. So it depends on what you started with. So if it was a multi-step problem, like I said, I'll be lenient. Okay, then we'll be good to go. Okay, so what I'm going to be doing here, got too many tabs open. There we go. Just showing you guys what I got. If you guys at any point need to pause the video to check my work, you can do so. That's up to you guys. All right. So number one, basically, if you double the mass, you got to double the force. All right. So that double of 3 would be 6. Number two, basically, it's pretty self-explanatory. The velocity continues to go forward. It's kind of like it's in an orbit, where our centripetal acceleration is always going to the center. Okay. A car that is moving around a circle, guys, if you're moving in a circle, you're always changing direction. And when you're changing direction, you're changing velocity. And when you're changing velocity, that changes acceleration. Okay. Let's see. This guy down here, he's standing still. When he's standing still, it's static friction. Okay. At the bottom, so the question said a carnival clown rides a motorcycle ramp around a vertical loop. If it has a radius, what's the slowest speed? Well, the slowest speed, there's not going to be a force normal. So the only force acting on it is force gravity, which is also our centripetal force going towards the center of the circle. So I had mass times acceleration equals mass times velocity squared over r. The mass of the object of the carnival clown, is the same, right? So those two cancel. So you have the acceleration due to gravity is equal to v squared, velocity squared, over 18. And that was given in our problem over there, 18. Okay. Solve for v. And that's how you solve for number 5. Moving on to the back. All right, a lot of work here. All right, so I'm given my time. My time was 5.94 times 10 to the 7th. 5.94 times 10 to the 7th. My velocity was 2.41 times 10 to the 4th. And I had to solve for r. All you had to do is plug it into the v equals 2 pi r over t, solve for the radius. Okay. Number 6, part A, just how to use the force, universal gravitational force equation. Plug in all your numbers. Now on the bottom, it's Earth was given in kilometers. Above its surface in that many kilometers, you had to convert that to meters and add that to the radius of Earth. Okay, you had to add that to the radius. And that solves for A. Okay, part A. Part B says, what is the speed? Okay, so if you check this out, what is the speed? This is a little more complex. So what you have to do is, I solved this on a separate piece of paper, is I plugged my number in. If you used 5,000 there because that was the previous answer, that is completely fine. But so force is equal to mass times acceleration. So we solved for that's how you solve for centripetal acceleration. Okay, I got this number. You put acceleration into our centripetal acceleration equation, which looks like this, and you solve for velocity. And from that, that's your answer. That's your final answer. Okay. Ask what is the velocity. Okay, so that was that problem. Okay. Number 8. Number 8 says Neptune orbits the sun with the orbital radius of that, and its mass is of sun is that. Calculate the period. So using the universal force equation, we have the mass of Neptune on both sides, right? Because force of gravity is equal to mass times acceleration. Okay, so acceleration, centripetal acceleration is equal to our g constant, mass of the sun, over r squared. Okay, so when you plug that into our equation, centripetal acceleration is equal to that. Then what you're going to do is you're going to plug in that into the centripetal acceleration, which is equal to v squared over r, which that's our radius. That will give you v. Okay, and then from v, you're going to plug v equals 2 pi r over time. So we know our radius, once again, it's radius again, and you just solve for time. Okay. And then on the very bottom, uh, so gives us, this is 0.2, oh, it gives us, the length of the string is 0.24, gives us the mass of the unit. So first, having the mass, so force of gravity is equal to mass times acceleration. So our force of gravity is actually going to be equal to the force of tension in the y direction. Okay, so solving this, you get force of gravity is 4.7, which means our force of tension in the y direction is 4.7. So it says find the tension in the string. Well, we know our degree. We know our force of tension in the y. Let's find our force of tension on the string. So using cosine of 15 is equal to the adjacent over the hypotenuse. The hypotenuse force of tension is 4.9. Now it says find the period. So now what I'm going to be looking for is my force of tension in the x. Okay? My force of tension in the x. So is equal to mv squared over r. So finding the force of tension in the x, you can do this multiple ways. I used this. I used sine of 15 over my equals hypotenuse. I use that to get f of x. Okay. Now that is equal to my centripetal force. Okay. So if you plug in my mass, v squared over 0.06, the way to get 0.06 is you know the length of this string, you know it's a 15-degree angle. So the opposite and the hypotenuse, so cosine of 15 over the opposite over hypotenuse. Okay, that's how I got 0.06. You plug that in and you'll get the velocity. Okay, so that will solve for velocity. And then you can plug the velocity. What did I do with that paper? You can solve for v, plugging it in 2 pi r over t. So you're solving for t there. Okay, so this velocity right there, you're going to plug that in, go down to there, and solve for t there. Okay, and that's how you could get that answer. Okay, so that is the test. In addition to the test, what I did was I went over some slides about momentum. Okay, so I talked a little bit about momentum and impulse. So if you need to pause the video at any time, please do so. Okay, so momentum is equal to mass times velocity, and momentum is signified by a p. So p is equal to m times v, and this is the unit for momentum, kilograms times meters per second. Okay. So if we look at that, kilograms meters per second, momentum is mass times velocity. So which would have the greatest momentum? Well, We can clearly throw out c because there's no velocity. These two have velocity. Do they have the same mass, though? Well, hopefully not. The truck has a larger mass, which means larger momentum. Okay? If you look at this problem, once again, if you need a pause, please do so. If you look at this problem, it says, what is the velocity of a 5 kilogram object? So if I know momentum is equal to mass times velocity, I know my mass is 5. It says, what is the velocity if my momentum is negative 15? Well, the opposite of multiplying is dividing. So divide by 5, divide by 5. Velocity is negative 3 meters per second. Okay, and that's how you would solve that type of problem. And then the last slide I showed today was impulse. Impulse is the change in momentum. And you do not need to write all of this down. It just shows how you can derive force equals mass times acceleration into force times the change in time is equal to the change in momentum. Okay, so impulse is the change in momentum. Okay, and that's all we did for today. Tomorrow I'm going to continue going over momentum and some impulse. So if you guys have any questions, please send me an email. We can always set up a Google Meet or anything. Just let me know. If not, I hope you have a fantastic day, and we'll see you tomorrow.